Welcome to solverfy.
All right, 46 is a bit of a wordy question, but we'll take it one bite at a time. So we're supposed to use ray diagrams to show that a real image formed by a thin lens is always inverted, whereas a virtual image is always upright if the object is real. So for the first part, that's relatively simple. The only time that we can get a real image is by using a converging lens, and only if the object distance is greater than the focal length, like I have drawn here. The image is going to be on the opposite side of the lens as the object, and it's going to be inverted. So we can see that by tracing some lines. First, we'll draw one up here, which, due to the angle, is going to, due to the angle of incidence being perpendicular with the lens, it's going to take a hard turn and go through the focal point. Ooh, go off this way somewhere. And then the line that goes straight through the center will not be affected. So it goes off like this. And then finally, the one that hits, that goes through the focal point here and hits the bottom of the lens is sharply sent parallel. So the image formed is here, which we'll call I. And no matter where you move this object, so long as it's outside of the focal length, it's never going to have this image flip over to be on top. That's never going to be the case. But for the second part of the question, we can see that for virtual images that are formed by converging lens, if the object distance is less than the focal length, then the outgoing rays are never going to intersect. So to show you what goes on here, it's probably quickly going to get messy, but I'll do my best. So the one that goes into the center here takes a slight turn and goes towards the focal point. Oh, sorry, that's not center, that's parallel. And the one that goes up here goes parallel. And then let's have one that actually goes through the center line. And let's say it goes that way. So if you were to have this picture suddenly be good and then trace back all these lines, they should form a cross point at some imaginary image over here, which we'll call I prime. But obviously I've kind of failed in the angle of some of these lines. This one should be a little bit more steep so that they all go back here at some point. But you can do a similar thing where you move this object anywhere in this range, and you'll see that these rays are always going to form this same type of image. And then finally, for the third case, where we have a virtual image formed by a diverging lens. So this is no matter where the real object is placed, because the rays that leave the lens are going to diverge. They're never going to form up on one single place. So they can't form a real image. And since the rays that hit the lens are at some point going to be sloping different ways, you're always going to have an intersection point with some other rays to make an upright image. So to show you what I mean here, if we draw a parallel line, it goes in here, and then it's going to come out shooting somewhere like that. And if we have, if this is the center line here, it will go into the center and then just keep going through. So that's the secret of these convex diverging lenses. And if you trace this back, you're always going to get some image, I prime here. And it's always going to be upright and vertical. So to answer the question for 46, pretty much all of these figures are needed to describe why you get inverted images for the converging lens, except whenever it's an imaginary image, or imaginary, when it's a virtual image, and you always have one for the diverging lens.